important muscles in breathing. The diaphragm muscle. The diaphragm is a dome-shaped muscle resembling a parachute. A parachute, or sometimes I feel it also looks like a jellyfish, guys. Have you seen a jellyfish? Sometimes it also looks like a jellyfish. That separates the thoracic cavity from the abdominal cavity. It plays a crucial role in breathing by contracting and relaxing to change the pressure in the chest. Now, changing the pressure and the volume of the chest, this is exactly where the Boyle's law comes in. This line here is where they are trying to talk about the Boyle's law. The primary respiratory muscle, diaphragm, can be considered as the principal muscle of breathing, single-handedly capable of producing on its own all of the three-dimensional movements of breathing in the thoracic and as well as in the abdominal cavity. So the diaphragm divides the upper cavity, the thoracic cavity, from the abdominal cavity. All the organs we were reading about, the spleen, the gallbladder, the liver, and etc., they all are underneath here. And the lung and the heart are simply here. And do you see the shape of, do you see the outline, the superior outline of the diaphragm here? It also resembles like it's directly on top of the liver, guys. If you'll see the liver underneath the diaphragm, the liver's top of the liver, the head of the liver, is very much having this similar shape. The heart is somewhere here, and the lungs are here. I'm sorry, I'm not Picasso, so I'm not good at drawing here, especially with the mouse. So the diaphragm is the single most important muscle. And this muscle is innervated by a nerve that originates from the C3, C4, and C5 cervical vertebrae. C denotes cervical or cervical. This nerve is known as the phrenic nerve. You guys can write it down. Phrenic nerve, P-H-R-E-N-I-C, very important nerve. The phrenic nerve innervates the diaphragm. Okay. Now, let me tell you a very interesting fact about the skeletal muscles. In architecture of yoga also, we studied about most of the major skeletal muscles. Skeletal muscles are coordinated by the somatic nervous system. And somatic nervous system is the part of the nervous system which is voluntarily manipulated, which is the part of the voluntary nervous system. Then there is the involuntary nervous system. So think about this. The diaphragm is a skeletal muscle because it has tendons in it. It has belly of the muscle in it. And I'll also talk about a very interesting fact that why diaphragm is special and different from other skeletal muscles. So the diaphragm comes under the somatic muscles, comes under the skeletal muscles. Skeletal muscles are those muscles that attach to the skeletal system. Suppose my biceps is a skeletal muscle. The head of the biceps is somewhere here. The insertion of the biceps is somewhere over here, my radial bone. When I command my biceps to contract, the biceps can contract and my elbow can flex. Another interesting fact, muscles can only contract. Muscles cannot stretch. The entire system of yoga asanas is dependent on the antagonist muscles, not the agonist muscles. Suppose if you want to stretch your hamstrings can't stretch by themselves. You, in relationship to acquire that stretch on the hamstrings, you have to contract something which is opposite to the hamstring, the flexors. So you will contract the flexors of the hip. That contraction is important to achieve the stretching of the agonist muscles here. The antagonist and the agonist works together. Try to understand. So I'm trying to say you that muscles can only contract if you give them a command. Muscles can only contract if you give them a command. If I want to move my finger, I'm giving a command. If I don't, I stop. Now, why do you think that when you sleep, the diaphragm is still moving? What is it that the diaphragm is still moving? The diaphragm, see, sharing another interesting facts with you. Now, science stuff will overload you. Sometimes it might overwhelm you. Breaking a myth here. The lungs cannot inflate and deflate by themselves. They cannot. The lungs are not muscles. They are different set of tissues that single-handedly can't inflate or deflate. They cannot. To do so, they are dependent on the muscles like the intercostal muscles and the diaphragm muscle and the negative pressures of the pleural cavity. We will see pleural cavity in the coming classes. But for now, write this down and remember this forever, that the lungs by themselves can't inflate or deflate. They are just there hanging. What makes the lungs inflate and deflate? The first primary muscle is the diaphragm, which means the diaphragm, now being a musculoskeletal muscle, is still functioning while you're not aware of it, while you're asleep. The heart, again, see, like there are systems in the body that works even while you're asleep. Like when you're asleep, what if the heart says, okay, I want to take a break now. He's asleep. His conscious mind is shut. So I will also sleep for a while. You will sleep forever. Shortcut to enlightenment. But the heart has a very intelligent structure to it, which is known as the SA node, the sinoatrial node. The SA node will send action potential to the muscles of the heart, which will make it beat. The lub-dub of the heart will never stop because of the SA node. But diaphragm doesn't have an SA node. The diaphragm doesn't have such kind of a intelligence thing. So there is a center in the medulla oblongata, the stem of the head. There is a specific population of neurons there that will send an action potential to the nerve, the phrenic nerve, every time you inhale. So muscles can only contract. When I said that every time you inhale, I didn't say every time you exhale, because exhale is very passive, inhalation is active. Muscles can only contract, hence contraction will be active. So the diaphragm can only contract. The relaxation is a byproduct. If you have inhaled, naturally you will exhale after that. Even to receive something, you have to give out, right? So we'll read about these centers, these interesting centers about, and we'll also read about the specific part and what it is named upon. Right now, just go superficially. At the medulla oblongata, there is a culture of neurons. These neurons will send an action potential every time, every fraction of second, that will go and send the signal to the phrenic nerve. Through that phrenic nerve, it will allow the diaphragm to contract and relax. Basically, to contract, the relaxation will happen passively. To contract, to contract, to contract, to contract. It will constantly send those messages. So these neurons work in a very involuntary manner, whereas the phrenic nerve cannot. The phrenic nerve cannot. So diaphragm is very interesting, guys. Out of all the vertebrates, only mammals are the ones who have developed a diaphragm in the evolution, in the course of evolution. Birds don't have a diaphragm, reptiles don't have a diaphragm, amphibians don't have a diaphragm. But I guess I was reading about this article on alligators. Maybe alligators have something similar, but it's not a diaphragm. It's called as the hepatic piston. It works in a similar way, but it's different. And all these vertebrates, except the mammals, they have active exhalation but passive inhalation. Whereas we as vertebrates, the mammals specifically, have acquired a diaphragm through the course of evolution, which makes us different, that our inspiration is active, but expiration is passive. For these other animals, the expiration is active, while the inspiration is passive. I hope we all are on the same page. You can see the recording if you are missing out few words. Okay, so we will see the diaphragm structure ahead. What do you think needs to pass in between the diaphragm? Now there is something up here, guys, and then there are few things down here, right? In between, what do you think should pass through the diaphragm? There must be things that needs to communicate between the upper cavity and the lower cavity. Any guesses? You guys can turn on your mic. There must be some stuff in the upper body and the lower body which constantly needs a connection, right? Any guesses?
Nerves.
Nerves, okay.
Can you repeat the question once more?
I beg your pardon.
Can you repeat the question once more?
I beg your pardon, Myra, once again. You want to ask me a question? Repeat the question. Can you please repeat the question? Is this what you're asking? I'm saying that there are things in the thoracic cavity. There are things in the thoracic cavity that needs to communicate with the abdominal cavity, the stuff which is there in the abdominal cavity. What structures possibly could be that is piercing through the diaphragm?
The vagus nerve.
Okay, the vagus nerve.
With the food pipe, maybe?
Yes, very good. The esophagus, the food pipe, because it needs to, it's connecting the upper cavity and with the lower cavity, the mouth with the anus. Okay. And very good, everyone. Come on, try. And few nerves, the esophagus, and you're forgetting something very important. Come on. What is the heart doing up there? Time pass?
Pumping blood.
Pumping blood. So some blood vessel needs to go down also to the stomach, right?
Yes.
Blood needs to move up and down through the arteries and the veins. Okay, chalo. So we will go ahead here. This is the diaphragm from underneath. So I'm having a POV of from the liver's side, from the stomach side. So this is a inferior view. नीचे से ऊपर को देख रहे हो. You're looking at the diaphragm from the underneath up. That what is up there. So there will be few words. The first word is hiatus or hiatus. This word means an opening. See, do you see these words? Hiatus. Sometimes we also call the caval hiatus or the opening. Here they have used the word opening. Hiatus or hiatus, this word means opening. So we have three main openings here. See, this is the first opening. This is the second opening, and this is the third opening. And the diaphragm is not totally ovule shaped like a parachute. There is also the spinal column here, due to which it has a curve kind of a structure like this. See, it has this curve here, this curve here. Sorry for ruining this. I will erase this. You have this curve here. So this here, whatever you will see in blue from now onwards will denote that it passes into it the deoxygenized blood. So we will talk about the arteries, the veins there. So the biggest vein is the vena cava. So the superior vena cava will be above the diaphragm. The inferior vena cava that takes the deoxygenized blood from the lower organs to the heart, back to the heart, so that the heart can now put it to the lungs and the lungs can breathe and take fresh oxygen in. This hole here will bring the upper vena cava go all the way down to the lower body, to the abdominal cavity. So vena cava passing through caval opening or caval hiatus. Then this here is the esophagus. We will also see the relation between trachea and esophagus in the next week's sessions. Esophagus means it is simply the food pipe. Someone answered food pipe. So food also needs to go down, right, to the stomach, because the stomach is underneath, but the mouth is above. So through the food pipe, it will go down. It is not like the trachea. The trachea will end into bronchioles. It will go into the heart, that's it. But the food that is gulped in through peristalsis, the process of gulping in the food will go all the way down to the stomach. So there needs to be a hole in the diaphragm from through which the esophagus goes down. Esophagus in the British style of writing, it starts with an O sometimes. Then this here is the aorta passing through aortic hiatus. Aorta is the biggest artery. For now, understand like this. Vein has to do to bring the deoxygenized blood towards the heart. Artery has to do with taking the oxygenized blood from the heart to the rest of the body. So whenever the heart will pump fresh blood that the liver might need, the spleen might need, the pancreas might need, it will go down through the aorta. And there needs to be a hole here. Then do you see these legs kind of a structure here? They are known as cruras, C-R-U-R-A-S, cruras, but plurally cruras, singularly they are known as crus. So this is the right crus, this is the left crus. This is the right crus and this is the left crus. You can imagine the person is facing to us, that's why right goes on this side and the left goes on the other side. And diaphragm is special because the diaphragm has the tendon to the center. All the white part of a muscle is the tendon. It cannot contract. Whereas the red part is the belly of the muscle. Those who are the ex-students here, those who have passed out from the course architecture of yoga, do you remember that the ends of the muscle are tendons? Like I was talking about biceps. The point of origin of the biceps and the point of insertion of the biceps, that originates and connects from the bony structure and that connects to the end of another bony structure, is made up of tendon. In the center there is the belly. The belly part is where it will look very reddish, very pulpy in nature. So the red color outside here is the belly of the muscle and the center is the tendon of the muscle. Now this is another exception of the diaphragm muscle, that it has its tendon to the center. Otherwise all the tendons of a skeletal muscle is towards the skeleton, where it intersects to a skeleton, where the muscle articulates with the skeleton. The bellies are to the center, but diaphragm has a tendon to its center. It doesn't have a belly to the center. So this also makes it a different kind of a muscle. So like I told, like in the previous course architecture of yoga, I remember I always used to give these little hacks to the students to remember stuff. There is another hack here, guys. So where do you think these holes are present? In front of which vertebral body? There is a very easy hack behind it. So the caval opening, if you'll see the word vena cava, just calculate the numbers of the alphabets here. 1, 2, 3, 4, 5, 6, 7, 8. VENACAVA, 8. So this hole is just in front of the 8th thoracic vertebrae. It is in front of the T8. And then if you'll see the esophagus, like I told you, in the British system, it starts with the O first, OESOPHAGUS, which makes it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this hole this hiatus here for the esophagus is in front of the T10, the thoracic 10th vertebrae. Then we have the aortic hiatus here. How many words here? Aortic hiatus has 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12, this comes directly in front of the T12, the last vertebrae of the thoracic spine. So this way, sometimes people, they also prepare for their PMT exams or any medical kind of exams they are preparing for. There is always a hack, but I would say remember principles. The language of anatomy is very much based in the principles. If you remember the principles, you know exactly what someone is talking about. But this is a hack. There is no principle to it. You can just remember it like that secret poetry behind a math formula. Okay, so this was the diaphragm. I hope you've made notes about the diaphragm. Here they have some other muscles. We have the psoas major muscle here. We have the quadratus lumborum. We cover all these muscles in the course architecture of yoga. Very, very important muscles. I'm not getting into these muscles here because they have nothing or very less to do with respiration.